but my name is Sophia Armstrong. I am a current computer science major at East Carolina University. I'm really excited to be graduating in May, so I'm looking for jobs. If your company is hiring, please come talk to me after. Please come to me. So back to business. Today I will be discussing a blockchain database for a cybersecurity learning system and the trendy technology I get to play around with when implementing it. So first, a little background on this project and the cybersecurity learning system. So each student will have 10 virtual machines for their defender environments, and then an additional environment for their attacker, which, as you can guess, will be used to attack the other students' defender environments. And the objective of this system is to provide a game-based learning experience. So we really want to make sure we keep an accurate score of the interactions between the students, attackers, and defenders. So my team and I are using Bash and Python scripts to monitor these interactions between the students' virtual machines. And this information is going to be sent through a firewall in syslog format. So we have this additional security just up front, a firewall, and then our blockchain database is going to sit behind that as an additional security precaution. So our quest for the best and most secure technology has led us to discover BigchainDB. So a little bit about BigchainDB. BigchainDB is an open source blockchain software with the following characteristics. It is decentralized. There's no single point of control, which means there's also no single point of failure. It is Byzantine fault tolerant, so up to 1/3 of the nodes can be experiencing arbitrary faults, and the rest of the network will still provide consensus and operate smoothly. It is immutable, which is more than just tamper resistant. The data, once it is put on the blockchain, it cannot be changed or deleted. It can only be updated with later chains in the blockchain. It has a high transaction rate and a low latency, which solves the problems that typically arise when having large amounts of data on a blockchain. It is also providing customizable assets, and an asset is just the data that's stored in your blockchain. You get to decide what characteristics go into that, what are the attributes and whatnot. And then on top of all of that, we still have indexing and querying capability for the data in the backend database, thanks to MongoDB. So as you can see, BigchainDB really takes the best of both worlds of a typical blockchain and then a distributed database, and it just merges it all together for a super secure system. A little more on BigchainDB terminology and how it all works together. So a BigchainDB node is a logic machine running the necessary software, such as the BigchainDB server software, MongoDB, which is the backend database, and then Tendermint, which is the software that provides the blockchain functionality. A BigchainDB node is accessed and created using a BigChain HTTP API or a wrapper for that API, such as a BigchainDB driver. It comes in multiple languages, such as Python, which is always exciting, and JavaScript. And a BigchainDB cluster is at least 4 BigchainDB nodes working together. And a BigchainDB network is a cluster of BigchainDB nodes performing consensus. So here's a nice graphic of everything I discussed kind of all working together. You have your node, your MongoDB in the backend, your server software, and your Tendermint providing consensus algorithms. And that's pretty much what our system looks like. We had 4 computers distributed. So yeah, I hope that excited you, and you can check out BigchainDB. Thank you.